So why would I want to do this? Well, I'm making a combinatorial library of similar chemicals to test their biological activity. So combinatorial synthesis, the small beads, well in fact they're resin beads. This is what's called solid state chemistry, where you put the chemicals on little beads, do the chemistry, and then you can wash them off easily afterwards. And A, B, and C, well they could be something like amino acids, chemicals that will chain one to the other to the other. Oh, those green arrows should be pointing to the C, my mistake. So those could be amino acids or any other chemicals that can sequentially bond together. First of all, we're going to put them all into a container, and that's called mixing. That's the first half of the mix and split method. So mix them all up together, there we go. Whee! Now split them up into 3 separate containers in this case. So each one is now going to contain some A, some B, and some C. To these, you're going to add a whole bunch of A, and then a whole bunch of B, and a whole bunch of C to the third one in this case. And reactions will take place. Now what you might notice is that in every one of these 3 containers, we're making 3 different chemicals. So from starting with 3 different chemicals, I'm going to end up with 9 different chemicals now. Each one is a combination of 3 different chemicals. So you could think mix, but actually it's the mix and split method. You mix them up, you split them up, you mix them up, you split them up. You don't need to know more detail than just mix and split. I started with 3 chemicals. You saw me get 9 different chemicals. If you carry on, you get 27, then 81. And if you don't switch the machine off in time, you'll take over the entire universe with that horrible geometric progression. Parallel synthesis, we'll take a little look at how this is set up. This is also called, unusually, teabagging. So I'm going to dip my A into the A. Then I'm going to dip what I've made into the B. And then dip what I've made there into the C. Lovely. So I've got AA, BC. And just by dipping your tea bag of chemicals from one container to the next, and this can all be automated actually, you're going to make a different set of chemicals each time. And so this is a very simplified version. The real machines have 144 little containers. So you can make very, very complicated, but in a way similar chemicals as you go along. Alright, so this is a summary based on past exam answers. In green, that's true for both of them. Large number of similar compounds, it's automatic, small scale, these resin beads are important, and it's the same reaction sequence applied to many compounds. And if they asked you to contrast the processes, combinatorial makes a larger library than parallel. Combinatorial is mix and split in the same reaction vessel, even though that sounds confusing, that's their answer. And parallel synthesis is in different reaction vessels. Right, I'm not even sure I understood that myself until I had to make this video, and now I think I get it. Hopefully you do. If not, just learn these in front of you.